We are live, and thank you everyone for tuning in, listening to another two Upside people rambling about fantastic Upside program and what we do, what we are, and what we do for living because we love this stuff. Right, Brooke?
And it's important. It's important. Oh, Frank, thank you so much for having me. It's always great to talk to you. I mean, what viewers may not realize is Frank and I actually get together and talk about this stuff when we're not in a webinar. So I love your
We
passion
do this on
and
a
your
regular
dedication.
basis. We do
Yeah,
this
I
on a
love your
regular
passion.
basis with two
It's
upsec
true.
people that talks upsec stuff, even outside work.
Yes,
uh,
exactly. This not to make money because we care. I mean, yes, we
yes,
all need to make a living. I'm not denying that, but yeah, there's more to it than that. A lot more. This matters. Let me just say,
absolutely.
what we do really matters, whether we make a living or not, and we hope we make a nice living. What we do actually matters. So let me set some context. So some of you may know me, some of you don't. I've been around, kicking around a long time, and this is far from the first webinar I've done. And you can go find me on the web. I've written a bunch of books or co-authored a bunch of books and pamphlets and industry efforts to make things better. Lots of them. I think Isar Tarandash and I are up to 6 different industry things we've done together. That's a lot.
Yes,
And that's all since 2014, which, we're packing in a lot here. Um, but yeah, the context here is important, I think, for everyone to realize. Evans data, and I did look at their research a little bit, estimated in 2019 that by now there would be 27 million programmers on planet Earth. And that number doesn't have to be accurate. Whether it's 25 or 32, it doesn't really matter. It's a lot. And the
I think
majority of
Tanya.
those, think about it, the majority of those people are not working in a mature AppSec program. They're just writing code. So
Yeah,
they're doing their best. I'm not wanting to dismiss anyone's work, but they're doing this work without benefit of a lot of skills and with only the knowledge they can bring to their work, which in my experience is usually fairly limited because what AppSec is fairly complex. It has a lot of domains that you need to be aware of in order to make it work. And because of that, all of those programmers who are not in programs, let's say 20 million as a guess, are writing
hmm.
vulnerabilities right now. Just
So, bro,
consider that.
before we dive in, I think that I was chatting with Tanya, and I'm just back from Dublin from Global AppSec. Um, I think we mentioned the fact that right now there is a ratio from the latest GitHub research of 500 developer to one security person. So it's challenging for security people to actually interface even with all of them or even few of them. But before we dive in the conversation, I want to set a little bit the scene. So tell us a little bit more. I'm not gonna say anything about me because I'm boring, but you have the more interesting parts. And as I always refer to you, you're the elder of application security. You hold the history of, and you've seen the evolution. And maybe I want to pick your brain on the evolution and if we are really evolving. It's a topic that we always talk about. But yeah, tell
Well,
us a little bit
that's
more about
an
you.
interesting question because there's a lot of folklore out there that drags us down. That's another conversation we'll have sometime. But it's true. When I was offered Cisco InfoSec's very first application security architect role, the way it was pitched to me in early 2001 was, I know this is a little bit of a down for you for what you're currently doing for us, as I was doing some design work for InfoSec. I know it's kind of less important, but we really need this role filled. That's the way it was pitched in early 2001 because everything was about networks and worms and viruses on endpoints. Everything was about network protections. And so application security was kind of, and it didn't even have that name. I mean, they were being really forward thinking to have an application
Mm.
security architect. This was very forward thinking to think about filling a role, such a role, because it was kind of a hindsight. It was kind of a, yeah, so write some coding stuff so we can bring the developers, rein them in from making mistakes, but it's a sideshow. And that's literally the way it was pitched to me. And none of us would have predicted at that time that my team, including the satellite, the Federation architects that we had, as a total effort, would become one of the largest and most important teams in Cisco InfoSec in just a few years. That's the history here, is as attackers realized that applications are pretty easy to exploit and can help them prosecute their goals. That's the way attackers work. Whatever is easiest, whatever works.
Right.
They don't really care if the thing they're leveraging is part of the operating system, part of the application. Right? They don't have these distinctions. We have these distinctions for a bunch of reasons that are maybe good reasons. That's okay. We could talk about that sometime. Why we have all these distinctions in security, but from the attacker's point of view, who cares? Man, I got this thing that's down here deep in the open source stack, and it gets me where I'm going. Great. Or I need to fiddle with some stuff inside this application. Great. It all works. They don't care, and nor
Like
should they.
identifying target, point the gun, and then shoot. Well, it's a little bit more sophisticated than that, but
It is.
they
It
don't
is.
have to deal with the politics. They don't have to deal with the organizational structure. They don't have to deal with, like, let's not step on each other's toes. And I think that is always what I've seen as an important awareness for us in application security, because I think our role is very hybrid. We are a little bit of politician, a little bit of salesman, a little bit of developer, a little bit of security people, a little bit of a lot of stuff.
I've never heard anybody say that, but we talk about the human side and the communication, and we do talk about that stuff. But I've never heard anyone say it that way, and it's true. It's really true. Thank you. That's so true. I'm going to quote you, Frank, because it's so true.
Thank
We're a
you.
little bit of all these pieces that you have to have some skill in, or we won't be effective. It's kind
Correct.
of frightening the places. I tried in Secrets, my book Secrets of a Cybersecurity Architect. My publisher insisted upon that cyber there. I didn't want it, but you know you don't get to decide these things. If you write books, you'll find out. um, uh, they have their needs. um, in that
I
book, I
know.
tried to list as many things as I could brainstorm that I've had to touch technically, and it just runs the
Hmm.
gamut of computer science.
Yeah,
Everything
it's
from,
a full stack.
how memory and stacks work, how operating systems talk to hardware, all the way up to big major, how systems integrate and global points of presence and content distribution networks, totally different than how a program is loaded. And yet I've had to touch all of these different things and learn about them and be at least reasonably conversant and understanding of them in order to do my job. It's really broad. And then there's the human side. Like you say,
Exactly.
nobody's
There
going
are
to
two
do
human
anything
side.
unless they're willing to talk to you. Go on.
And I think that's the two human side. As I said, the shift left and the shift up. The shift left with the developer conversation where you have to educate, convince, and then there is the shift up. There is the whole business perspective, human aspect perspective, where you need to evangelize and try to convince the business that is for branding image or for not getting hacked tomorrow for several reasons that is nothing to do with upsec, but very much to do with risk and business risk that you have to convince.
And
And
business culture. My friend Nooper Davis, who is a light, a long time light. I mean, she goes back to early Carnegie Mellon stuff in around the same time that I'm talking about Cisco InfoSec. She goes back to that same time. She's an executive vice president at some big company now, many times awarded for her work, but she calls it culture hacking. I love that. As a geek, as a fully admitted, wear that label, geek, nerd, techno nerd. She calls it culture hacking, and I love that. You have to be able to look at a culture and say, how can we tweak this so that things will go in the right direction? And I'll tell a very quick story. When I got to McAfee, it's old history, long before the current execs that were there. Its old history was really pretty bloodthirsty internally, and that anybody who'd been around a long time knew that if you had learned years ago, not in our administration, not with the execs that I worked with, I don't want to mispaint them. Let's go back in history here. It's an old company. They had, it was kind of, you stick your head out of the foxhole, you get shot. So people had learned to really be quiet and never say what they thought should change. And that's not the way I do my AppSec. It's not the way I know anybody who's effective does AppSec, all command and control and shut up and do what I say. That never works. Not with developers, not with smart developers. And
smart business.
these are, yeah, and really smart people, right? And driven people. And so, I had to prove to them. I used to go into James Ransom's office. We were working together. This is not the first time, and he's my boss, and say, you should fire me. I'm really unsuccessful. It's not working this time. It was a joke, right? And I knew he wouldn't fire me, and he would laugh and say, keep doing it, keep working on it, and it was kind of a private joke between us. But I felt so ineffective because I was working against this old culture, which had been totally command and control, totally bloodthirsty, totally cutthroat. And I wanted to get people on my side to culture hack this thing so that people would all feel like they were pulling together, and that we could share and be vulnerable and talk about our mistakes and fix things and not worry about whether someone made a mistake. Yeah, everybody makes mistakes. I've made lots. Horrible ones.
And I think that's an important point, because there is a fear that if you show that you made a line of code, a piece of commit, or something, and there is a vulnerability in there, you look bad, and that doesn't stimulate the conversation a lot of the time. And that's a big culture change that I've seen. It takes the longest to get into, depending on the size of the world. Because on the Asian side of the world, for example, in my history, you never say that to your boss that you've done a mistake. So for me, it took a long time coming from the Western civilization that's the mindset. And you need a framework to allow them to express those things in a bit of a more anonymous way that in the Western culture, it doesn't exist. So it's also geographically located culture hack. And I think there is not enough people talking about this.
There really isn't. I mean, people like Nooper are extremely skilled at this. Um, there are people who are very, very skilled at this game, but we don't talk about it. Someone like, I'm gonna literally name names of people who are really great at this. Someone like Dustin Lair. This is one of his geniuses. His ability to walk into an AppSec program, spot the cultural stuff, and start shifting it towards a place where people can work. And yes, you're right. There are cultural differences, and sometimes, hopefully one is aware of that, what is culturally appropriate. But sometimes you do have to just be blunt, I'm afraid. And sometimes, when people are using their cultural, and I've had this happen to me, various cultural pathways to manipulate a situation, sometimes you have to confront that. And, it's a really tricky razor's edge, and sometimes you don't make friends. And that's never a good thing. It's really tricky. The cultural side of this is ever fascinating to me. And I'll just tell you that my first degree is in anthropology, not computer science.
Nice.
And so, it's just endlessly fascinating to me,
I think
the nature.
the best computer scientists actually don't come from computer science degree. I'm a hybrid physics, maths, and computer science major, so I've done a little bit of everything. But what I really want to do is psychology.
Well,
But then
it's all
I also
important.
wanted a job
Yeah,
in
well, me
computer
too.
science.
I've made a lot of more money in high tech than I ever would have made in anthropology. Where you have to get a PhD and you have to get into a university and get tenured, and then you have a nice life. Yeah, it's a great life, but I've made more money. Yeah, it's true.
But
Security people get so listeners, remember, security people get a premium in their salary. It's a good career.
but I think I always go back to Daniel Carnegie and saying if you skill in the human side, no matter what's your job background, you're always gonna do better if you're skilled in dealing with human. And I think for AppSec is a must. But I wanna maybe take it back to where we started. That was how do we go about application security, and culture is very ephemeral. But then you have other measures that can tell you, like you saying, things are going good, things are going bad. There are certain gut feeling that if you have experience, you can telltale sign. But there is also other stuff that are clearly measurable. So how do we measure, in your opinion, the maturity of an AppSec program? Or how do we say, okay, we're doing good or we're doing terribly bad? Let's keep on doing and double down on this activity, or let's totally stop that.
So that's a great question, how you measure it. And I'll start with don't do this. Don't count vulnerabilities. I might, and that is the most widespread risk measure in information security, and it is completely wrong. Why? Because um, something between 85% and 74% of what is reported as CVEs never get exploited. And I've seen different
Correct.
studies, and that's why I'm saying there's a range there, because it depends upon which study you look at, what the right number is. But it's a majority. At least three-quarters never get used. And so counting vulnerabilities, we know in that pile of vulnerabilities, implicitly, we know there's some risky stuff.
Yeah.
And there is probably. But teasing out the right stuff has been a difficult problem, and we have not approached it well. We can talk about that later, but don't measure that. And in the same way, when we talk about the sort of hand manual or human analysis parts of AppSec, like threat modeling, number of threat models turned in is ridiculous. It doesn't mean anything, because one person, one of your architects, your security architects, or whatever you call them, might have something so complex they can only do that one threat model for a year, and another
Mm.
person has got 40 little things and they're cranking them out because they're little. You can't compare one threat model to another, and it's because they vary in complexity and how unique or not unique they are. And so how much work you have to do, research and whatnot. So they're not really comparable. Um, and so number of threat models, or number of projects turned, or so let me tell you, start with the security architecture side of this, because that's one place where I've had put a lot of thinking into what can we measure. First off, my very first measure is, because development teams are very conscious of their time, they will disinvite anyone who doesn't add value to the next meeting. That if a person is disruptive, or they don't add value, or they're not seen as contributing, and they're not essential, they'll just get disinvited from the next meeting. So my very
Ad
first
invalid.
measure, literally, yeah, my very first measure for my architects is, are they getting invited to meetings? And if and so another measure is, if I'm having coming back to me having we can't get enough time of X person, you know, we're having trouble getting enough time of this person, and I know that person's working instead of playing, and turning out work. That's a great sign. It means they want that person. So it's very simple, but it's very, very accurate, telling you whether people are adding value. And the next thing that I look at is how many requirements, and this is something you have to measure, how many requirements coming out of analysis actually get built. That's the effective measure. So someone who writes a lot of requirements and none of it ever gets built and it all becomes exceptions or waivers, that's a bad sign. At the same time, if you never have a waiver or an exception, that's also a bad sign, because eventually you're going to have to say, over my dead body, this is really important. And some, director's going to say, no, over my dead body, I'm going to take the risk because I need to do other things. You should have a little conflict there. It means you're being effective and you're standing up for security. Not too many, and you got to set a baseline. What is the normal baseline?
Mm-hmm.
And watch your best people, and you'll see what the baseline is, and then measure that against other people. See, these are really unusual measures, aren't they? I bet you've never heard them
They
anywhere
are.
else, because this is the real stuff. If people get stuff done and people actually deliver requirements and those get built, that means they're being effective. If they get the odd exception, that means they're being effective and they're standing up for security. If they're not, they're being a little too nice and a little too accommodating, because eventually you're going to have a conflict. But if it was exceptions all day long, then that speaks to their inability to do the human side of these things well. There might be a
But
great architect.
isn't
Think about
the
it.
exception? I always talked about exceptions and the increased amount of exception on architectural kind of creaking. Like when you define a policy or you define a structure and it's too limiting, and there are too many exceptions, that could be also a telltale sign.
Oh, yeah, good point. Good point. So you want to always be crafting it. That's true. And you always want to be crafting. I'm very careful about policies. Something I learned at Cisco many years ago, because of course we made this mistake, is don't write policies that people have to go around in order to get their job done, even if it makes your policy a lot weaker.
Mhm.
What you want and what you can get done are not always the same thing. And so write your policies so that people want and can meet them, even if it means writing a weaker policy, because people who are motivated will try to get their work done. And if they have to go around the policy, they will. And I don't want to turn my developers into liars, basically. I
Mhm.
want to turn them into allies. And if the policy is impossible, then they're going to go around it. And I've just turned all of my developers into my enemies. And that's kind of the wrong
Right.
direction, right? This is something I
You
learned
don't
at
want
Cisco
that.
a long time ago. Be very careful about what you write in policy. My favorite is an Intel policy that I had to have changed when I got there as their version of distinguished engineer, was do not call any banned functions, any banned C functions, assuming back in that day everything was written in C. Except by the time I
Right.
got there, we had Go, we had tons of JavaScript, we had all these things. So this policy was meaningless to these people. So they said, "Oh, I must not have to follow that. I can call anything I want."
Mhm.
No, it was too specific, and it made all kinds of assumptions about and nobody bothered to change it. Instead, the AppSec people were running around trying to tell people that
Enforce
they
it.
couldn't call any bad C functions. And then there's the people, they had a Linux kernel, and there you have to call the dangerous functions. It's part of the way you write the Linux kernel, right? And so they couldn't comply. It's a
But
terrible
dangerous in
policy.
terms of deprecated, or dangerous in terms of like
Oh, like
directly
calling.
indexing memory.
Yeah, no. I think the banned C functions were, things like, um, uh, oh God, my C is so. It's been so many years since I programmed in C.
Alloc
Um,
and getting
yeah,
into
things like
memory.
direct string copies instead of the safe string copy, stuff like that. There have been those safe versions of the earlier API for years, and they just wanted you to use the safe thing. So we rewrote the policy so that it made sense to everybody. It wasn't that hard. But this is an example of a really bad policy. Somebody was really upset at some point and wrote their problem into the policy instead of thinking about how things might grow and how you, and then you call for language specific standards, and you can change those easily without. Policy, you got to get legal, HR. There's a whole execs. There's a whole process to getting those things in place. You can't just declare your own universe. Nobody's the king except the CEO or the queen. It's not that easy. So you don't want to change policy very often. Anyway, that's a whole art. And talk about arts that we have to play. There's a whole art in and of itself. There's nothing to do with
Yeah, and
AppSec in a way.
there is a whole branch of people that write policy and standards, and the whole category from top down, that is an art. And especially I've seen that happening, especially in big organization, when you can be like super generic at the top level, and then you have policy that are interlinked with policy, because at local level there might be region or line of business that are completely different than the global view of the world. And that's in general saying
Yeah.
like the two things are disconnected. But let me not get into that politic
Let's not
disconnection.
run down sorry to take us down the policy, but it's just an example of what we were talking about. But so you measure those things, and then let's talk about measuring the testing side. One of the interesting
Mm-hmm.
things we did find at McAfee that really was a measure we had not been measuring, but we started to measure because it was a measure of effectiveness, and I want to get this out there for everybody to grab. And it was a complete surprise, by the way, or sort of a surprise. Intuitively, it makes sense, but we hadn't thought of it. And that was as we began to measure what kind of things were being reported externally. And remember, as a security company, the security researchers are reporting stuff constantly. And you may not have that luxury. I mean, it really is a luxury to have brilliant people looking at your stuff and looking for stuff in your code. But we had that luxury. But if you do, something you can measure is what they report. Because when we started the AppSec report, of course, the AppSec program and the measuring these things, what we were seeing coming in was the same stuff we were finding with our testing, which wasn't universal and wasn't ubiquitous, which was, some people weren't getting the cross-site scriptings and the SQL injections and the common errors out of their code. And so we're getting a lot of those reports, and they're easy to find, right? A lot of tools for that. As the years rolled by, and we're talking about 3 years here, so AppSec programs take a while. Be patient. But as the years rolled by, we saw very little of these kinds of reports, very few. As people were doing threat modeling, and it was ubiquitous throughout development, so they were thinking ahead of time of what they needed to do. And as they had good tools and were getting the usual stuff, the easy to find, the low hanging fruit, as they say, out of their code, the reports we were getting from outside changed dramatically. We
It's a good
started to
telltale
get,
sign.
well, if the moon is in this phase and it's close to Saturn and they're almost conjunct, and we turn these three admin controls in a certain way, then we can get at this driver buried deep in your code and maybe get some flow control that we didn't have before. But everything has to line up really hard, and we really worked hard at this. It took us 6 months to find it. That's the stuff you want security researchers looking for and finding for you, because it's really hard to find in testing. You're not going to be able to find that stuff with your own unless you have a really great red team. They're not going to find that, and they may not have time to find that. And your pen testers may or may not find deep stuff like that, but securities researchers, bless them, we really need that. They have the time and they get the career benefits from spending the time to find that stuff. And that's the stuff you want them to find, not the easy stuff that you can find yourself. They should be finding this really hard stuff. And over the years, we had very few reports. By the end of my term, after almost 6 years there, did we have very few reports of easy stuff. But hard
That's a good
things,
outcome.
that's a really good measure of your effectiveness, a really good measure, right? And let me just say that threat modeling being architecture, which you're trying to reap the long tail of architecture in the security space, which means nothing proves an architecture like nothing. This is one of my favorite sayings. I coined that, but it's very hard to measure, in other words, because what you're trying to do is measure no drama. But if you can measure no drama, that's a sign that your architecture is actually somewhat elastic, somewhat flexible. You can update it without major churn, that you've planned ahead, and that incidents are minimized. I didn't say you wouldn't have incidents. They're minimized and you can deal with them. And that's the sign of great architecture right there. Nothing proves an architecture like nothing, like quietness, like just normal operations. That's the sign of a great architecture. So you want to measure that. You do want to measure that. You want to measure the amount of time you spend on incidents and the amount of effort it takes to respond and deal with them. Because when they're minor and you have a great architecture and you have a great incident team and everything's in place, it's a lot easier than when you've got all the helpful execs creating an email storm. I bet this has happened to you, Frank. All the execs are creating a major email storm about, are we doing anything? What are we doing? We should do this. We should do that, because they want to
you
help and they don't
you
know that
discover
everything is in process and being taken care of quietly and orderly. I
you
love those email
discover
storms.
remote part of the organization during incidents. A remote execs or hidden execs during incident. Everybody has an opinion and a voice.
Well, right. Well, I love the person who is still has a job, who has very bad self-control and explodes over something that's actually being taken care of. Those are the most fun. And in large organizations, you always have one or two not very nice people who think that being a exec is a matter of being able to scream at people. You always have one or two of those people, unfortunately. Most of us get it, that when you're an exec, you're a servant to the people that you're working with, but not everybody. And unfortunately, cooling those people down, it's one of James Ransom's great superpowers. My
But you
dear
mentioned you
friend
mentioned
James Ransom.
something. You mentioned something that I think it's a really good value, and I've been thinking lately of it. Like, and Tanya mentioned it in OWASP today. Um, Looking at security incident, especially AppSec related security incidents, bug bounty, bug report could be a very, very good tool to then sponsor your AppSec program, because you say, look how much time and effort we spend in post mortem and fixing those things. We could kill this stuff at the very source. Like you say, McAfee, we get a lot of basic stuff from report. We spend a lot of effort trying to figure out what, and then listening to people reporting on it, and probably it's in the news at some stage, um, depending on the size of the organization, because security researchers want to go very public with any findings that they might find.
That's
Um,
how they make their living. Literally,
um,
that's the reward. If you don't get any direct remuneration, it's our economy of vulnerability. If you can stand on the stage at Black Hat and do something very, very tricky, you can increase your salary potential by factors. And
yeah.
it's just the way it is. I don't want to get into the whether that's a good thing or a bad thing here publicly. Talk to me privately about it, anyone. But I don't want to go there. Not in a public forum. But I want to say that is the reality of things. And there's this personal satisfaction. I found this thing, sure, but there's some very real benefits to standing at Black Hat or DevCon and doing something, demonstrating something new and novel and interesting, and that's the way it
I
is.
like that.
We
I,
in AppSec need researchers because they find the hard stuff. They have the time and resources and skill to do it. Adam Shostak wrote a great, so many years ago now, a really terrific blog post about why in engineering you need critique. And unfortunately in AppSec we don't get critique in the way that it should be. Like if you build a bridge, they have other people who come in and critique your work and look at your calculations, and we don't do that in AppSec. So researchers provide us with that, and it is critically important in my very strong professional opinion. Without the research arm, we would not get the critique that says, hey, you designed this thing in the 90s and then you built it into processors in the 2000s, and it did make things a lot faster, but actually the junk left around in the speculative caches can be misused, and you didn't think of that. That's unbelievably important. There was
yeah,
nothing
keeping
wrong.
us on the toe.
I'm talking about Spectre Meltdown, and I just want to say there was no design error. It works as intended and as designed, but that's new research that points out that, yeah, it's critique to that design. That's really important.
Yeah, Spectrum Meltdown, though, it's pinch of salt. My pinch of salt is very hard also to execute. Like you want those reports,
Yeah,
you want things to be hard to execute. You
you
don't
do.
want an XSS on an OpenSSL library pointing out,
Yeah. I
because
mean,
that's been thoroughly discussed.
yeah, exactly. And I want all that brilliance pointed at stuff I need that I can't do myself. Um, so yeah, and there are different business contexts here. That's another piece of this puzzle. So take Google, who throw application spaghetti on the consumer wall, on the internet wall, essentially. Plus which they have a huge amount of infrastructure that does a lot of the security for the application writers. So they can benefit from that. And so that's really cool. But they can also throw
Mhm.
up an application and then they stand on a stage and say, yeah, we don't need to test this thing. We're going to let people find it out in the public while the application
Because
has all this. But
they have
that's
a
their
very
business
specific
model.
rule.
Yeah,
They
that's
have
their
a very
business model.
specific rule and policy in Google that says no security researcher internally can open ticket unless they're super thoroughly high quality tickets and super thoroughly verified. That means 80% of the issue, like the 10% get open and probably a high quality ticket. But think about how many testing we need to do in order to identify like this is exploitable, it's exploitable in this context, it is very high signal ratio in this particular event, and how many
Yeah,
security engineers. Okay, you Google, you have tons of security engineers, but we might
yeah.
miss a
And not
lot of
only
stuff.
that, they can afford them. So, they
Yeah.
can benefit. Every application writer benefits from that. Okay. Compare that with someone that writes security software. Anybody in the security biz. The first rule is you do no harm. You have to make sure, you have to do everything humanly possible to make sure that when somebody puts your software, starts running your software, it doesn't open more vulnerability than it closes. You have a very different security requirement there. Or if you're in fintech, people expect that people won't easily be able to steal all your crypto coins, right?
Well,
Well, that's,
unless they are,
whether
unless
they
this
do
is
it
the
or not,
business
that's
model.
the expectation, right? And so you have a much higher bar to hit than somebody who does something different. And so it's just, you got to look at context. You always have to look at context and what do I need. And that's one of the jobs of a AppSec person, is to understand the business context and the risk tolerance of the organization for whom you're working.
But you're describing a very mature upside person. The challenge
I
that we
am.
have in this field, and I face it all the time, is there are not a lot like us that have had that war path, seen it all, done it all. There are very few of us, and the majority of Defender and Blue Team are actually start getting the baby step in AppSec. AppSec has been around for publicly, I guess, the last 10 years. And privately,
Yeah.
like OWASP, it's been 20 years. So AppSec is very new.
23 years for me. 23 years now. Okay. And if you talk to someone like Gary McGraw, even longer, because Gary wrote his definitive, foundational book. It was published in 2002. I mean, let's get real. Um, software security. I think that's what it's called.
Mm.
2002. Yeah, some things have changed, but Gary, we're standing on Gary's shoulders and Nooper's, because they were doing it before me, right? Um, and we, it's been around for a while. In fact, here's an interesting thing. It was 1976, when Schrader and I forget the other person's name wrote software security principles. And you know what? Those things still apply. They're still completely applicable. If you go look at Schrader's and the other person, I forget their name, and I'm sorry, it's escaping me right at this moment. Software security principles, they still work. And every vulnerability that I put into InfoSec's very first coding security guidelines, those are still issues today. Every one
Mm.
of them. And it's old vulnerabilities don't die. They just wait until you're not paying attention.
Some of them do, though. Some of them do slowly die, and I think that's been my thumbs up to a lot of frameworks like Rust, like new modern framework, or even Java. And I think there's been a recent debate around writing in C, and we shouldn't write in C because you can just point up pieces of memory. That is a very, very bad thing to do, because it can be great if you are programming at a very low level, but it can be very nefarious if you know how to exploit it. And there are modern frameworks that actually have eliminated those issues
Well,
altogether
Rust
with
for
memory
one.
boundaries. Yeah.
Rust for one.
Um,
Um, and it's getting really wide adoption because they don't even have a garbage collector anymore. They're doing it a different way, so it's really fast now. I was just reading a whole analysis of its history, Rust. And some other languages. I think Apple's Swift is a lot cleaner than writing in
it,
C and
it
C++.
will take ages. It will take ages because a lot of the stuff that we operate on, I mean, we still have mainframes in financial institution. We still have COBOL, and don't get me wrong, COBOL is really secure because nobody knows how to write exploit for COBOL, or nobody knows how to write COBOL. Periods. So if you want a career and very lucrative career stuff writing in, maybe C is still around, but COBOL and mainframe stuff, it's really lucrative because there are very few of them.
Yeah, well,
But
that's because
Java
they're
is
all
still.
graybeards like me. That's my first language, by the way, COBOL. Um, I never
I
did it
started in
professionally,
assembly.
but that's what I learned in my master's was COBOL. Um, and it set me up. I have to say, it set me up. It gave me enough to learn other things. But yeah, COBOL. But nevertheless, yeah, very lucrative. You're right, because it's people my age or older who are doing it, and
But
making some money.
jokes aside, coming back to the measurement, I really like the outcome-based measurement because it's really the black and white. Are you doing something right or are you doing something wrong? But there are, I think, nuances, and I agree and disagree with you on measuring the vulnerability because if you don't have any other way to measure stuff, and if you're doing the baby step, I'm a big fan of actually evolving your measurement.
Well,
Um,
that's true.
and
I'm talking about very
here's the critique.
sophisticated measurements. I am that are hard to get, and you have to have
Exactly.
some. You have to set it up and know about them and get them. It's true. I will admit, I'm a bit blinded, perhaps, by my experience level,
I
and
call you
so
dreamer.
it's good to point that out. But seriously, measuring vulnerabilities, um, especially if you can winnow down, if you're using something that winnows it down to stuff that has some chance of being exploited, and there's some tools around that. There's a couple of companies working on better prediction models. I don't necessarily want
EPSS.
to. Yeah, I don't necessarily want to say I endorse any particular company around this, but there are companies working on it. But there's also EPSS, which is
It's
now, I
open.
mean, you literally can just with the smallest little bit of Python, go out and say, give me those things that have a 50% chance of being exploited. And if you were keeping that score, I would agree, because now you've winnowed down in some way to a reasonable set that says, yeah, I should pay attention to this stuff. And if I leave this stuff open, I'm leaving it open for a while, and that's a risk. Yeah, now once you winnow away some of the cruft, I think you start to, and there's a tool, EPSS. It's public, it's free. You
Yeah.
can just write, and
And it
I
has an
even put
API.
out a little bit of Python on how to do this a year or so ago. Said, hey, do it this way. So, EPSS and their little toy website, not good at scale. But now you can do it at scale. You can just say, give me all the things that I should worry about. And it's some
There is an
percentage,
API. We created an API. So I'm part of the EPSS group. So
Yeah,
now you
that's
can
that's what I'm
query the
talking about.
API.
Yeah, it's very easy.
It's
And
very
you can
easy.
say, now there's one issue here that's really important, one caveat, really important. It only goes back to April 2021, I believe. They decided not to do the history. So fix your old vulnerabilities, okay? I know lots of people have legacy from way back. We were just talking about it, but fix your old vulnerabilities as best you can. It's not going to help you with that. But for the new stuff, and somebody who's just starting and they don't have that legacy, they haven't built up their legacy yet, the baby steps, just worry about the stuff, pick a number out of the hat, and you can always change it. Let's say I want 50% predictability of exploitation. you know that's a good place to start. Maybe you have high security needs and I want 20%, or you have fairly low and you want 75% chance. You got to pick a number somewhere, and then go with that, and that'll tell you what to fix. And measuring that is a very good idea as a baby step. I agree, Frank.
Yeah.
Very good idea.
And it kind of kills. I'm always a fan of this like quick win, easy method because we we are too busy as a security professional to actually roll the wheel that is a square wheel. I don't know if you know that. I always have in mind that joke that is we're too busy rolling a square wheel to innovate and use the action wheel.
And actually
And
round it. You're right.
exactly. Um, so we're too busy actually triaging and massaging and convincing the rest of the organization that we never get to writing policy, writing structural things that could affect and have a much, much wider impact than just fixing day-to-day vulnerability. We don't get that 80-20 rule. We get the 120 rule that is 100 times on vulnerability and then 20% on in your free spare time, look at the insight and maybe actually build a system that will get the data that will give you the insight. And then on the other spare 20, so now you're on the 140 rule,
Well, so
you can create something.
let me just jump in here, and I think part of that is again, it goes back to culture hacking. So one of the things I've done after my first stint as an application security architect, where I was doing as much myself as I possibly could, and at one time I had 140 projects assigned to me. Luckily, only 2 or 3 of them needed my time most weeks, so it wasn't that hard. But 140
It's a lot.
just gives you a sense of I'm doing everything or too much, right? And of course, that's what we do when we care. But learning how to delegate, I learned because Michelle Koblis, who is a light in this industry, by the way, she's just fabulous. Michelle Koblis and I were so desperate. We were sitting in her office. She's my manager, going, we're never going to hire enough security people. What are we going to do? Well, what if we came up, sort of independently invented, parallel invented, the federated model out of desperation. Now, I know other people had invented it as well. I'm not claiming I'm the only one by any stretch, but we independently and parallel invented it because we were desperate. We were just, I don't know how to solve this problem another way. That lesson, and it was a very successful program, by the way, when it happened. Within a year, everybody was asking us, how did you do that? That was under the leadership of Nazrin Razai, but that's a different story. Michelle had gone on to other things, but she gets credit for sitting around and trying to figure out the idea with me. It wasn't me alone; it was her and me in desperation. But nevertheless, after that, when I saw the power of that, I've included in my AppSec program delegation and training. And so the way you get out of that, so you have time for strategic stuff, is you got to empower people to actually execute and give them room to make mistakes and give them room to learn and practice and do it, and all of that training stuff. And when you do that, we the leaders who do have the experience, or who are learning to get the experience and who need to have time for strategic, start getting recouping some time. You've got to hand it off. And that's why I coined the term developer-centric security. After doing that a couple of times, I said, this needs a name. And yes, I'm the one who coined that. It was my idea. You can go on my website, brooksshoenfield.com, and look, and you'll see the time. If anybody else uses it, they should reference me, but they never do. But nevertheless, it was my idea to coin a term, developer-centric security, because the idea was, if they can at least do some, I get some time back. I'm not doing it all. And so all my programs have focused on that. It's really important. Besides, as James likes to say, James Ransom, if you can't trust developers with security, they have the code anyway. So what are we doing with this idea that we have to hold on to things? They can do anything to the code, or we trust them to do security. I mean, that's one big security thing. I don't trust them. I don't trust them. Or that was a thing for many years. I don't trust them. And believe me, I have heard many a security person, I just want to say, demonize developers in their language. Don't do that. Most of these people are really capable and very smart, and they want to do a good job. They just don't know what to do. So that's our job, to help them.
And ultimately, they can do whatever they want. So if they want to go to prod with an insecure
right.
design, they will find a way to get around your CI/CD block, because that's their job, and that's where they're going to get paid for, and that's what they're gonna get the bonus for if they got a. I've seen a story of people that say, "Yeah, I got around security and security block. I wrote a hack." No, you wrote an exploit, but that's a different thing.
Right, but that's
Yeah.
true. Again, don't make your partners into your enemies.
Hmm.
Why? We're working together to solve these problems. So I like to say, this is my little litany. Every day when I come into work, the important question for me is, how can I enable and empower developers to innovate and be creative securely?
I love that, but I would
You
also
know,
say,
rather than
and I
me
had
being
this.
the big cop. It doesn't work anyway, but especially when you're dealing with smart people. It's different maybe in a factory setting where people want to constrain their job, and that's very different. We're not talking about a factory. We are talking about really creative, smart people who mostly want to do a job. But I'll tell you something, and this is entirely anecdotal. I don't have hard data here, but I haven't run into a developer in years who looked at me and said, "Oh, security, that's somebody else's job. I don't need to worry about that." Not in years. I think we've won the mind share battle, at least in the development teams I work with. And it's fairly a lot, as a consultant. I talk to a lot of developers. It's not scientific survey, but I haven't run into a developer who looked at me and said, "No, that's not my job." Not in years. They've all said, "Yeah, we have to deal with security, but can I get my job done?"
Hmm.
And that's so I think we've won the mind share battle. Now it's a skills and knowledge situation.
Yeah, they
I
want to
think
know
we could
how
stop
or
worrying
what.
about whether they care about security and actually worry about the security. You see what I mean?
Yeah, but I think not every security person is a coder, and I think we have this fear, and because of we have this fear, we never show our vulnerabilities that vulnerability that we don't know how to code. So we go into a meeting and we don't want to write stupid policies, and the developer don't want to get impacted. We never get sit around and say, okay, how we solve this? I don't know about how to code. You know how to code. I know about security. Let's get together. Let's figure out this thing because we don't have enough upset people that know how to code. I'm rusty, so rusty, and sometimes I get stuck and I say, honestly, you better than me at coding. I know security practice and security. Show me and let's figure it out together. But that requires a lot of vulnerability, and sometimes we're not taken seriously because of that. And I think that's a stigma that we need to change in order for everybody to be able to do OPSEC.
Yeah, I mean, we can't. I have seen people who are non-coders be very effective in AppSec, but they bring a lot of humility and partnership to the discussion, and that makes up for a lot. And it's a bit cultural too. There are certain cultures on the planet, well, they will push you to see how deep you are to find out who's deeper. And in those cultures, if they find out you're a lightweight, they'll stop paying attention to you. It's a good thing that I have written hundreds of thousands of lines of code. Rusty does not describe my skills anymore. Obsolete. But I have written hundreds of thousands of lines of code, commercial code, some of which is still running. So uh, that that helps. That helps a lot. And I've got the computer science background now to talk about the problems, and it's clear that I'm a techie. It's true that helps, but it isn't necessary. I want to encourage everyone, if you want to jump into AppSec, it isn't necessary, and it also can be learned. I like to use the example of my daughter, who leads data security at Tinder. I'm very proud of her. I always get her into these talks. Somewhere. No, not
Kudos.
always, but a lot of the time. So forgive me, but she's a good example because she's a really brilliant. She was working towards psychology, and then she took a hard turn into tech, and she studied hard on her own, and she learned enough to get a paid internship where she learned a lot. And then she used that to get another paid internship. And now she leads data security at Tinder, you know,
That's
years
amazing.
on. Yeah. I mean, people should know my daughter's not a child. She's a grown up. She's in her mid-30s. Yeah. So she's well into her career now. And obviously, and has some, serious responsibilities. But, um,
It is possible for
it
people
can be
to.
done. It's just a matter of solving problems and looking at how things work and understanding, and you learn as you go. So, I would encourage people to you don't need to be a coder. No, it helps. It certainly helps to understand other people's problems. But if you're good at understanding people's problems, you will just sit down and understand their problems without actually writing their code. The more important
You
thing is
don't have to.
understanding their problems, right? Is
You can come
understanding,
up with a
look,
solution together.
well, we're back to the people stuff.
Hmm.
You can't escape it.
But that's why.
Really, I don't
That's why
think
it's
you
so
can be.
hard.
Yeah, I don't think you can be effective in AppSec if you really dislike people and you want to sit at a terminal. Become
No.
a penetration tester. That's a great field to go into for that mindset, if that's what you want to do. There's lots of jobs. Be a tool jockey. There's lots of jobs that pay very well in security. But AppSec is not the place for you. Because here it really about half of it is people.
I think you can do still triage of vulnerability. You can be a security engineer up to a point, and you can work on a certain set of very technical skill that doesn't require the human interaction, but really to be effective and really communicate and convince people. Because you can be the best coder on earth and talk to another best coder on earth and be confrontational and never agree on something, and you never get the thing done. And you can be completely agnostic of security or coding, and you say, well, the policy said this, maybe it's stupid, let's raise an exception. Or the policy said this, maybe we can do this authentication in a slightly different way, maybe using HTTPS or more crafty way. And then if the other person say why, and then you say, maybe, you see being a little bit of threat modeling, and with a 10 minutes conversation, you have an ally.
So
And
I'm
you're
going
not
to
a coder.
argue everything you say is true, but I'm going to argue a little bit that the person just qualifying vulnerabilities is going to need some people skills, because here's what it comes. The developer then looks at that and says, yeah, but that's not a vulnerability. I don't
Yeah.
think it is. Why is this important? Or they just say, why is this important? I don't see, it's not the functionality of this is a classic. You get this all the time, but that's not how it works. Forgetting that the attacker doesn't care how it works. They care how the vulnerability prosecutes their objectives. Very different mindset. They don't care how your application works. They care about how it misworks, how they can misuse it. And so very different mindset. So you have to be able to explain that things. Well, so classic example, tool, really geeky security person tells an exec, you have to close this cross-site scripting. And the exec says, I want a risk exception. But if you say
Right.
to that same exec, attackers are going to be able to use your website to hurt your customers. And if enough of them get hurt from that, you're going to lose your customer base, and people are going to lose confidence in your website and your services. Do you care about that? You see, this is a totally different conversation. Still the same vulnerability. I have never seen a exec say anything when it's explained like that, but why wasn't this fixed yesterday? Which is the
Contextualizing it
answer you
and,
want,
and
right?
translating it.
Right. But that's what I'm saying. Even just because you know what the technical details of it and it really exists, and you can look at the code and say, yeah, this really exists. There's still you have to convince the developer. You have to say to that developer, well, if you leave this in here, there's a good chance that an attacker will misuse it in this way. And we know attackers are misusing this sort of thing over here in this way. And it happens, with this regularity, whatever you think whatever you can research the regularity is, and you can explain all these things, then most developers don't look at me, at least, and say, yeah, no, I don't care. They go, oh, I didn't understand that. Oh, thanks for
That's why.
explaining. And they're really grateful that you
But that's
explained it
why
because
I'm
they just
such
learned
a.
something.
But that's why I'm such a big fan of risk, because risk enables you to convert and converse with a lot of business mindset people, and even risk and fair, that enable you to translate a monetary value of how bad it is, and enable you to have those kind of conversation with an exec and say, we have 40 million vulnerability. And the exec would say, so what? Your risk profile is this, and it's much higher than the rest of the organization risk profile. So your head is on the block. So you can risk accept it, but it will damage X amount of users because your application processes X amount of users, and you can potentially cause a damage of 1, 2, 3, 4 millions per day, hour, month. It's a totally different. Nobody wants their head on the block. And executives are very good at making decision of like, okay, maybe next week we have a big campaign, and if this feature doesn't go out, like I'm gonna lose my job anyway. So risk versus risk, like let's go with it. But then they are aware that that thing is burning. Instead of you have 40 million unrealized vulnerabilities, so what? We were alive yesterday, we will be alive tomorrow. It's not something that I think I've read, I don't remember whom, but I read the perception of a vulnerability or an event to happen. There is a probability, but there is the perception of the probability that is a very key things. And
That's brilliant. Yeah, that's
all of
brilliant.
that can
I
be,
want to unpack that because you said fair factor analysis of information risk. And the reason Jack Jones, I just happened to be in a sharing forum with him when he was developing factor analysis of information risk. It's an open group standard. You can go out and look at it. And to me, that is the best information security standard we have today. So if you want to know about risk, go read the stuff there. Go. It's
yeah.
totally freely available, and you can use it, and base it on it. And everything I do is kind of based in fair, even if I don't use fair exactly. But
In all
nevertheless,
fairness.
yeah. But so I wanted to unpack that for folks. But interestingly, I was in a security representing Cisco in a security sharing forum that Jack was in for Nationwide at the time. He was the CISO at Nationwide, and he was developing fair. And the reason he developed fair is for exactly what you just said. He would say, I would used to go in, and he was working in Nationwide as financials, so actuarials are the execs. They know risk, they know how to calculate it. They were pros,
Easy.
right? And he'd go in and say, I think this is bad, and they'd say, show me the numbers. I don't have the numbers. I think it's bad, and this is why. And they'd say, I accept the risk. So he developed FAIR, which is probably the most sophisticated thing that I know of at this time for
Yeah, it is.
calculating risk. And the maths are really cool. It's casino math, and it's really cool how it works. But go look at it. I don't want to dive down into that right now. But I'm sure as a maths person, Frank, you're just fascinated with it. It's just really interesting how it works. But anyway, he developed it because then he could go in and say, I have these numbers, and these are the
I have a
variables I
quantitative measure.
calculated, and a very
It's not
solid
an
one
opinion
that you're
based.
going to understand, that I can prove. And they would say, I can make a decision now. Thank you very much. And it really, really improved his practice. Now, the thing about FAIR, I'll have to say, and I've said this to
It's
Frank, to
complicated.
Jack. Yeah, it's a little hard to set up. It's really great at the GRC level, the global risk and compliance level. It's really great. So I encourage GRC people to get out there and use it. But for doing, when you got 20 things you have to measure in a threat model,
But you can dump it down.
you
You
need
can
to
dump it
deliver it
down.
right now to the developers, and they need the priorities right now. They need to know what's most risky and what's less risky. and they can wait on. It's kind of heavyweight, and it takes too long for me. I'll just say. So I've dumbed it down. And Vinay Bansal and I invented something based on FAIR called Just Good Enough Risk Rating. It's had thousands, by now tens of thousands of ratings. And so it's very field tested, and we've revved it. And Vinay has lost interest. He's gone on to an amazing career at Cisco, and so he hasn't looked at it in a long time. But I've revved it a lot through my books. And the latest version, well, the second latest version is in the last book, Building Insecurity at Agile Speed with James Ransom. That's our, the second to latest version, but I've revved it since then slightly. But nevertheless, that's something that I know works, and it's really fast. But if nothing else, let me tell you, when you have to look at a vulnerability, I think the most important, and unfortunately it's not part of CVSS, although we did propose it through Intel's participation in FIRST, and apparently they didn't want to do it, but or maybe they're going to do it in a later rev. But the most important measure is this contextual thing. Does prosecution of this, considering the context and what the attacker already has when they arrive at exercising a vulnerability, does exercising it deliver something the attacker needs and doesn't yet have? And I call it attacker utility. If it doesn't provide attacker utility, or the attacker utility is insignificant, you can ignore it right there. That one measure will be a filter that eliminates a whole lot of little stuff, a whole lot of stuff that's not important, because
that's very contextual.
It is very contextual. So you have to understand,
and you need
your context.
You need to do right. You need to do asset management. We don't even do asset management decently in organization. That's right. Why
and even the definition of asset is watery, very watery, and slightly contextual, because do you consider, I love it when security pundits get on the stage and say it's all about the data. Well, if it's all about the data
and context,
then you've just said you don't have to worry about people building botnets, because they don't care about your data. They care about your machines, and they don't care what you're doing with your machines, because they're going to do with them as they wish. And probably that will only slightly impact or somewhat impact what you're doing with your machines. You may not even notice they're sending child pornography around the planet on your machines, which is what they do, by the way. Horrible stuff, those botnets, when they rent them out. You don't know what they're doing. They're doing horrible things. And by the way, the reason I bring that up is my second incident response in my career. This is back in 99, I think, or maybe early 2000, was had included child pornography, one of our machines on the DMZ being used for, among other things. Horrible stuff. Horrible. So, you don't want a botnet, but that's not, typically they won't say that's an asset. They'll just, when they want data. No, assets has to be broader, and we have to look more holistically, and you have to understand attackers a little bit. But yes, a real understanding of your assets is important, is critical. I'm not a huge fan personally of lists of assets, because they change so dramatically, especially in a cloud ephemeral containers universe, which is where we are now.
Is something like having something, a list of something, is better to just guessing it, and having an interest or knowledge of what application you have. You can add contextual data to those applications.
Yes.
You can do automatic threat modeling.
Yeah, there are tools for that, by the way, that at least help. Something like AWS X-Ray, and I think GCP and Azure have complementary similar services. I don't know what they are, but I do know about AWS X-Ray, which will say, hey, the flows are going here and here and here. This is where you're actually using your stuff, and that's a start. That in a microservice empowered developer universe, where you may not be able to keep track of everything, running something like X-Ray or one of the commercial tools, or the freemium tools that says, here's the stuff we found, is really important. I think Lucid Chart also maps out, a cloud tenancy really well, and produces some stuff. There are a bunch of different things that can do this, and
But
you know,
that's a whole different talk. Like application security and cloud security that are converging together. I think we need to do a session dedicated on that. Um,
mm,
Brooks, we are running. Actually, we run a little bit over, but that's always happened
I'm
with me and you.
sorry. Once you
No,
start
it's
me, you put the quarter in. I just
it's always a pleasure to have like this discussion. I wanted to maybe take a punt of this that we love. I love data, and we wrote something together on that to actually how to measure things, and is more of the recent book that we published and white paper that we published. So I wanted to let people know about the existence of this, because we measure stuff, we show how to measure things, and as I said, I'm a big fan of not starting from the ending, but starting as a progress, and um, we have as well something baking to actually measure things, baby step,
and get
taking a
that book,
very
get
serious
that
of upside.
pamphlet. It's quite good, and they were, the authors were kind enough to allow me to take a look through it and make some suggestions along the way, and it's really interesting stuff, and it will improve your practice. I'm telling you. Take a look at the pamphlet.
Brilliant. For your kind of books, then where can people find your books and other
Amazon,
information?
Barnes and Noble, all the usual places. People often ask me, "Well, shouldn't I buy them from you?" Well, the truth is, Amazon's price a lot of the time is less than my price at wholesale, because they only give me 10% off. And while if
Interesting.
I get 10% off, then I have to charge you the full price, retail price. Whereas, I only get 10% of the wholesale price anyway. So, when you write these books, it's not about money. Believe me.
It's about sharing
When you
knowledge.
buy one of my books, I get $3. Thanks. I appreciate it, but it's not a big deal. But the more important thing is, can I share some knowledge? Can I help you? Can they help you? Go to Amazon or Barnes and Noble, buy it used. I don't get anything, but I don't care if it helps you. Then that's good. You can get Kindle editions. All the usual things are all true. So you can just find a copy and peruse it. And a lot of the books don't have to be read end to end. I try to write them so that they make sense end to end. I don't know if that actually works, but I do. Spend a lot of time thinking about that. But you can pick and choose. And this last book, we really tried to make it so you could pick and choose. Oh, I want to just go to the threat modeling chapter. Oh, I want to go to the software. What is software security, and what should I do? Chapter. Oh, I'm going to buy this book strictly for the generic SDL. I need an SDL, and it's worth it to me. We put it in the appendix. You don't even need to read the book. It should be obvious what you do, just in the appendix. So you don't have to read them end to end. If you want to read them end to end, thank you very much, and I hope you get a lot of useful things. But you don't have to read them end to end. They are meant to be taken, bit by bit as you need it. That's why I write them that way.
Brilliant. Brooke, thank you so much for coming on the show. It's always an absolute pleasure to talk to you about AppSec. And yeah, we need to write one together about the history of AppSec.
I'm so sorry that I was not able to get to Dublin, because all the cool people. I just want to tell you, Dublin OWASP, AppSec, all the cool people I know were there, and I am so jealous, so
Well,
jealous.
next time we do a talk together on the history of AppSec, and we can do this Patreon show, because I think it will be absolutely fantastic. Thank
Things
you
have
so much
changed.
for coming on the show.
Things have really changed. The way we do it is not the same as we used to. So that would be a good topic. Yeah, it'd be fun. Thank you very much for having me. I hope that attendees got something useful out of this.
Brilliant. Thank you everyone for listening in. We have a next event coming up on the 22 weekers from tomorrow. So we're gonna explore again application security and maybe a little bit more on the security chapter and the collaboration. So we will continue on this topic. Thank you everyone for listening and tuning in. Sorry we went a little bit overboard, but we're passionate about AppSec, so we never stop talking about it. Thank you,
We
everyone.
really don't. Someday we have to talk about our lives, actually. Take care, folks.
Eventually.
Have fun in Dublin.
Thank you, everyone.
Bye-bye.
Cheers. Bye-bye.